Okay, hi everybody. Welcome back to math class. So I hope everyone's doing well and you're keeping busy. This is going to be our first math lesson for our 3M math class. I will be posting everything on our Brightspace page, so please check this every day. I will be posting 2 or 3 lessons a week, not on a set schedule. My hope is that you'll just get those 2 or 3 lessons done by the Sunday of the end of that week. The lessons will consist of a short video lesson, most likely, unless I don't feel like there needs to be a video. Some practice questions with answers provided, and I'll go through those, and then a small exit card for each lesson so I know how you're doing with each topic. Those will be for marks, and those will probably be a quiz on Brightspace, and I will show you how to find that. If you want to connect with me ever about math questions or anything else, you can connect with me using the envelope icon on Brightspace. So if I exit out here and I go to Brightspace, if you, of course, this is happening. This is wasting some time. Okay, so if you go to this envelope icon here, if you click on it, you'll see instant messages come up and email come up. You can use either with me. I've never used the instant messenger, but it comes up like a chat box, and so you can certainly use that or an email if you'd like. Okay, so we're going to go back to the lesson. I'm going to repeat the periodic functions lesson that we would have done the second last day before the break. So these are periodic functions, and it came with a handout that looked something like this. Introduction to periodic functions. We had to fill in a couple tables. So all you needed to do to fill this in was for 0 degrees, you just put sine of 0 into your calculator and that would come up to 0. Sine of 30 in your calculator, making sure your calculator is in degrees, of course. This would be 0.5. 60 degrees was 0.87. 90 degrees is 1. And then those are really the only numbers you're going to see. And it's just going to start cycling back and forth. And as we hit 0, now it's going to go to negative 0.5, negative 0.87, etc., etc. I can let you do that if you'd like, if you want to fill those in. Most of you have done this in class already, so don't worry about it. Once we graphed it, we saw something like this. So let me present this again. So the sine function started at 0, 0. It increases up to 1, a maximum of 1 at 90 degrees, goes through 0 again at 180, down to negative 1 at 270 degrees, and then back up to 360 degrees at 0 there. Cosine, if we did that graph, is the exact same curve, you'll notice, but it's shifted. So now the peak of it starts on the y-axis. So it starts at 1 and goes to 90, goes to negative 1, up to 1 in 360 degrees. So if we look at the summary of these two, looking at sine x graph and the cos x graph, are these functions or relations? Well, if we look at the graph, remember, if we take a vertical line through a graph, it's never going to touch this curvy line more than one spot as we move a vertical line through the graph. Same here. That means these are functions. Okay. What about the domain? Remember, the domain is the x values. Well, it goes on forever in both directions for x. So x is going to be the element of the reals. And for a range, that's the y values, well, it goes between -1 and 1, doesn't it? So if we put those into our chart there, that's what it would look like with our mathematic notation that we have been using this year. So just some definition about periodic functions. So one cycle is the smallest complete repeating pattern of a graph. So you can see here, it starts at 0, it goes up, it goes down, and now it's back at 0, going up. See how these are both going up here? So that means that is one cycle. Okay, so that the part in red is one cycle. The period is how long that cycle is. So if these are ones, we'll assume these are one. It's 1, 2, 3, 4, 5, 6. This cycle has a period of 6 units, whatever that is. Okay, so that's period and cycle. Axis of a curve is the horizontal line that cuts the graph right in half. Okay, so here you can see it's the top part is at 2 and the bottom part's at -2. So the line that goes right through the graph in half is 0, y equals 0. So the equation has the form y equals whatever the number is that goes through the y-axis. Okay, one way you can find this is you can take the average of the maximum and the minimum. So if you go 2, no, it's not an average. If you go 2 minus 2 divided by 2, you will get your axis. But I just like looking at the top, looking at the bottom, and finding the halfway point. The amplitude is just the difference from your equation, distance from the equation of the axis to your maximum or your minimum. Basically, what is half the distance from top to bottom, okay? So if we do an example, oh no, first I'm going to do this. Just because this was on your homework and we didn't go over it in class, so I wanted to go over it specifically. When you're looking at a graph and determining if it's periodic or not, it can be confusing, especially with something like this. So this one, you can, I hope, clearly see this is periodic because it is the same shape. This is one cycle, right, between 2 and 4 here. And if you cut and paste it and put it right next to each other, you get the same shape over and over again. So how you can tell if something is periodic is because the y values repeat itself. Just like we did in the sine and the cosine table, you saw that the y values repeated over time. This one, even though it looks like it's a cycle, it certainly is. The period seems to be the same between, going from peak to peak distance, for example, but the y values do not repeat because this one gets up to this height, but the next time it gets to a peak, it's lower. So the y values aren't repeated exactly. So that means that is not a periodic function. So if we do an example, how can we find the period, how many cycles, equation of the axis, and amplitude? This is an example we did in class. So if you look at the period, you can see here it goes through the y-axis at this point, and at the same point on the curve is here, and that distance is 4. So the period must be 4. You do not have to use that method. You can use a peak to peak distance, for example. I kind of like doing that one because it's very easy to see where the peaks are. So this peak happens at 1 and this one happens at 5, and the distance between 1 and 5 is 4. So the period of this function is 4. How many complete cycles do we see? Well, we're going to start here and just count them. We're going to go, okay, it goes to here. Well, that's 1 full cycle, and then to here again, 2 full cycles. We have a little bit, but we're asked how many complete cycles are there. So there are 2. The equation of the axis, well, the maximum is 4 and the minimum is -4. So what's going to be the halfway point? Well, that's a total distance of 6, right? Because we got 4 units here and 2, so 6. So you think the halfway point is going to be 3 away from each end. So if I go 3 from 4, it's going to be at 1. And 3 away from -2 is also going to be +1. So the equation of the axis of the curve is y equals 1. So you're just going to put that in the form as y equals whatever the y-intercept is of that horizontal line. The amplitude is the distance from the equation of the curve, which is 1, to the top. So if I have something here and I have to go to the top, well, this is at 1 and this is at 4, so 4 minus 1 is 3, so the amplitude is 3. Okay, so what I want you to do is try the you-try questions. They are here right now. You can try to figure out the period of this function. E of a means equation of the axis. What's the amplitude and what's the number of cycles? This one has amplitude and the range. So that's, remember, the range is writing the bottom to the top. Once you try that, pause it here, give those a shot, and then the answers are on the next slide. Okay, hopefully you pause it and just didn't go forward, but these are the answers you should have gotten for those graphs on the you-try questions. So today, there is more practice on Brightspace. If you go to cycle 2, sorry, that should say, and then 2.7 periodic functions on Brightspace, there is more practice there. And I have posted the answers to those as well in lesson 2.7 on Brightspace. And you need to complete 2.7 periodic functions exit card, and that will be in the quizzes. I'll show you that in a second. Just a reminder, those cycle 1 test corrections are going to be due by April 10th, if at all possible. You've had much over a month to do that, so I'm hoping you had those done before time anyway. So let me show you where to find that quiz. If you go into Brightspace, we're in our class, and click on quizzes. And it's going to be right here. Here is the 2.7 period functions exit card. It's not going to be available until hopefully whenever I post this on April 6th, the Monday at 8 a.m. It's just 2 quick questions. It shouldn't take you more than 5 minutes. Okay, so I plan to do one more lesson this week. Yeah, it's going to be on transforming periodic functions as well. So let me know if you have any questions, and stay in touch and have fun. Okay, see you guys soon. Bye-bye.